know all those polyatomic ions you've been learning? Guess what? We're going to start talking about compounds with those. So, here's the thing about these compounds, okay? Don't get freaked out by them. Alright, yeah, they have lots of letters and numbers and things in them, but you already know these polyatomic ions. So, what you're going to do is you're going to name them just like any other type 1 and 2 compound. So, because you're looking at type 1 and 2 compounds, now, what type of compound are type 1 and 2? Well, they're both metal and nonmetal, and therefore they're both ionic compounds. So why do you think polyatomic ions are going to make type 1 and 2 ionic compounds? Because they're ionic, because they have ions in them. Alright, so we're looking at ionic compounds, but with these polyatomic ions. Now, if you think about it from that perspective, it makes sense, and you're kind of doing the same thing you've already done. Alright? So when you're naming these, you're going to name them the same way you do type 1 and 2. So type 1, no Roman numeral, just cation, anion. Right? But the difference is, if that anion is polyatomic, you don't change the name. So it doesn't necessarily end with "ide." Okay? You don't change anything. Alright? So, let's look at a couple of those. Alright, so here, we got Na2SO4. Now, Na is a type 1 cation. Sodium's +1, it's always +1, forever and ever, it's type 1. Right? So, Na2SO4 then has a sodium ion, and then it has this SO4 ion, which we know is sulfate. Okay? Well, but you say to me, but sulfate is SO4 with a 2- charge. Where's the charge? Huh? Okay, well, smarty pants, the 2- charge, look what it's bonded to. It's bonded to 2 sodium ions. It's bonded to 2 + 1s. So you got 2 + 1s, you got 2- charges, and so the compound itself, like every other compound ever, is neutral. So, SO4 is a sulfate ion. Okay? So, this compound has a type 1 cation, so that's called sodium, and then it has a polyatomic anion, which is called sulfate. And since it's a polyatomic anion, you don't change the name. You just call it sodium sulfate. The end. Okay? Let's look at this next one here. KH2PO4. Now, you will only ever have 2 ions in a compound. You'll have a cation, you'll have an anion. Alright? And so, what you've got to do is you've got to identify what's your cation and what's your anion. Well, KH2 is not a polyatomic ion. H2PO4, however, is. And so your 2 ions here are potassium and then H2PO4. Remember, H2PO4 is called dihydrogen phosphate. So the name of that compound is potassium dihydrogen phosphate. Again, you don't change any names or anything. It's just write the names out. Okay? Now, what happens if you have a type 2 cation? Okay, type 2 cations, again, remember, being cations that have multiple charges, right? Multiple possible charges. Well, you do that the same way you do regular binary type 2 compounds. Okay, so here you got MnOH2, right? So you've got 1 manganese, has a charge of X. You've got 2 OH minus 1 ions. So you have 2 minus 1 charges. And we know that that has to equal 0. So X minus 2 equals 0. X equals 2, and so that's the charge on your manganese. And so that's manganese, Roman numeral 2, hydroxide. Okay, that Roman numeral again tells you the charge on the cation. Okay? Now, NH4ClO4. Wow, there's a lot of letters in But you should recognize a couple of things. NH4 is a polyatomic ion. ClO4 is a polyatomic ion. This one has two polyatomic ions in it. It has a polyatomic cation and a polyatomic anion. Well, it doesn't have a metal with one charge or two charges, or there's no metal in it at all. So what type of compound am I dealing with? Well, NH4, ammonium. What's the charge on NH4? It's NH4 plus 1, right? So the charge is +1. Is it ever anything besides +1? No, it's not. So ammonium is a type 1 cation because it's always the same charge. Okay, so NH4 plus, ClO4 minus, ammonium, name of the cation is ammonium, name of the anion, ClO4, is perchlorate, right? So the name of that compound is ammonium perchlorate. Okay, again, you don't have to change any endings, right? FeNO3, right? You got Fe, you got one iron. This is a type 2 cation, right? Fe is a transition metal. You got one iron ion that has a charge of X. You have 3 nitrate ions. Nitrate is NO3 minus 1. Okay, equals 0. X minus 3 equals 0. X equals 3. So the charge on that iron ion is 3 plus, and so we call it iron 3 nitrate. Okay? Let's look at this. Last one I want to look at is this one right here. Okay, because I want you to notice something. Right? Again, you got that ammonium ion there, right? So you got ammonium, but look, your anion here is not polyatomic. Okay? You have a simple anion. Now, as we've already learned, simple anions, you do have to change the name, right? So your cation is ammonium, your simple anion is a chloride ion. So we call that ammonium chloride. Okay? Again, you just got to do these things to start seeing them and get better at them. Okay? Now what I want to do is, again, like we've been doing, go the other way. Okay? Start with the name, write the formula. Now, like I've already told you several times, okay? Unless you're dealing with a type 3 binary compound, how do you find the formula? You look at the charges and you switch them, right? It's no different here. You look at the charges and you switch them, okay? So, let's look here. We got copper 2 nitrate. We got copper, Cu. What does that 2 tell you? The Roman numeral tells you the cation charge. So, copper has a 2 plus charge. Nitrate. What is a nitrate ion? Well, it is NO3 with a -1 charge, right? So, just like any other ionic compound, switch them, and you get Cu, you get one of those, and NO3, 2. Now here's the problem. The problem here is, that looks like CuNO32. We don't have 32 oxygens in there. We've got 2 nitrate ions. Okay? Now, this is the only difference between this and any other ionic compound. Okay? We've got to show that we have 2 nitrates, not that we have 32 oxygens. So what we need to do is kind of group that polyatomic ion. So, you put parentheses around it. Okay? You only do that if you have more than one of that polyatomic ion. Okay? So, your formula is CuNO3, parentheses, 2, because you've got 2 nitrates, you need the nitrate in parentheses. Okay, notice nitrate is NO3. You're going to have NO3 in that formula somewhere. It's not going to change to NO2. It's not going to change to NO6. Okay, you're going to have nitrate. You're going to have NO3 in that formula somewhere. Now you might have 2 NO3s or 3 NO3s or something like that, but you're going to have that nitrate ion. All right, lead 2 carbonate. Okay, lead 2 tells you that you have Pb2 plus. Carbonate ion, of course you know, is CO3 2 minus. Switch them, you get Pb2CO3 2, but because it's an ionic compound, you simplify. 2 and 2, reduce to 1 and 1, and so you just get PbCO3. Note, there are no parentheses there. Why? Because there's only one carbonate in that formula. Right? If you only have one of that polyatomic ion, you don't need the parentheses. Okay? Potassium bisulfate. Right, again, potassium K plus, bisulfate, HSO4 minus. Switch them. You got a +1, -1. You got one of each, KHSO4. Okay? Look at this next one. Now, we've seen this one before. Right? Ammonium, NH4 plus, iodide, iodide is a simple anion. It's simply iodine, and the charge on iodine, because it's a halogen, -1. Okay, NH4 plus, I minus, formula, NH4I. Okay. Let's do one more quick example. Titanium 4 hypochlorite. Titanium, Roman numeral 4 tells you that it is 4 plus. Hypochlorite, ClO minus. Hypochlorite meaning you've taken 2 oxygens away from that chlorate ion. Okay, so you switch them and you get 1 titanium and you get 4 hypochlorite ions. Because you have 4 hypochlorite ions, it needs to be in parentheses. Okay? So you get TiClO parentheses 4. Not just TiClO4, that's titanium 1 perchlorate. That's something totally different. Okay? So, you got to be very careful about those parentheses because that changes the meaning of things an awful lot. Okay? But that's all there is to writing formulas with these polyatomic ions. Okay? And so now we just need to practice it.